Okay, so we have now this special case. This special case is that when an independent voltage source is connected to essential node with one node as reference node. So here is that special case that we have essential node 1 and reference node, and the voltage 100 volt is there connected between these two. So if you want to write the voltage equation, so what will happen if we write the voltage equation at node number 1? So we have V1, and you see V1 is the voltage at node 1 with respect to the reference node V3, node 3. So you see here this voltage is equal to 100 volt. So V1 is equal to 100 volt, and it basically constrains us to write the voltage equation from here. So now consider the voltage equation at node 2. So at node 2, we can write the voltage equation like this: V2 minus V1 divided by 12 ohm. So V2 minus V1 divided by 10 ohm plus V2 divided by 5 ohm, and this current is entering, so it will be equal to minus 5, and this is equal to 0. Okay, so we can rewrite this expression as V2 by 10 minus V1 by 10 plus V2 by 5 is equal to 5 ohm. So you see here we have one equation and two unknown. You can see here V1 and V2, but the information of V1 here can get from this connection, because this voltage source is connecting between the essential node and the reference node. So we can simply make use of these information to solve this problem. So here V1 is equal to 100 volt, so we can write this as V2 by 10, and this will be equal to minus 10 plus V2 by 5 is equal to 5. So this leads us to a solution that V2 is equal to and we can simplify here just to give you an idea. So it is 0.1 plus 0.2 and is equal to 10 plus 5 is 15. So V2 is equal to 15 divided by 0.3, which is almost equal to 50 volt. Okay, so something very simple and very easy. So just consider this factor also. So if there is a constant independent voltage source between essential node, two essential nodes, one essential node is reference node. So just make use of those information, and you can simply reduce the problem to a very simplified nature. So this is case number 1. Now we can consider the case number 2. Case number 2 is that when voltage source is connected to essential nodes, and these two essential nodes, we can relax this. So two essential nodes, and there's no need that one reference node is serving as a reference node. So let's have this circuit. So you see this circuit. We have essential node 1 here. So here essential node 2, and here we have essential node 3, and we have this node also essential node, and we consider this as reference node. Okay, so 4 essential nodes, and of course we need 3 equations to solve this circuit. So let's label V1, V2, and V3 like this. So voltage at node number 1 is V1, voltage at node number 2 is V2, and voltage at node number 3 is V3. Now, we have this current controlled voltage source, so it is dependent voltage source, and we have now this is I5 from where it is controlled. 4 ampere current is like this, and plus 50 volt. So simply start analyzing this circuit with node voltage method. Now consider node number 1. So we just discussed the example. So just remember that voltage and independent voltage source is there between 2 essential nodes, and 1 node is serving as reference node. So what will happen? We will just take this V1 as equal to 50 volt. So we can write this as V1 is equal to 50 volt. So now analysis is this node is down. So we will not consider this analysis at this node. Now consider node number 2, and write the node voltages at node number 2. So we can write the node voltages at node 2. So we have V2 minus V1 divided by 5, V2 minus V1 divided by 5, V2 divided by 50, and let's say one current is assumed here, and that is denoted by I. So we can simply say current is moving away here. So we can write this I is equal to 0. Okay. Similarly, considering equation number node 3. So at node 3, we can write this as current entering at node 3. So we can write this as minus I plus V3 divided by 100, and this current is also entering, so we can now write this as like this. Okay, so simply write it equation number 1. Okay, you can say equation number 1, it is equation number 2, and this is equation number 3. If you add the two equations, equation 2 and equation 3, this I will be cancelled, and we can write the resulting equation as V2 minus V1 divided by 5, V2 divided by 50, and this will cancel. So we will have V3 divided by 100 and minus 4 equal to 0. So this will be the equations. Now here, another issue, very interesting issue. V1 is 50 volt. So this unknown is gone. Now we have one equation and two unknowns, V2 and V3. Okay. Here is the tool we have to use to solve this circuit. And we introduce a concept, and that concept is the concept of supernode. Okay. So when we will be using this concept of supernode when the voltage source is there between two essential nodes, and that node is not necessarily be one node not necessarily be serving as a reference node. So here This is not a reference node, this is not a reference node, but there is a voltage source between the two nodes. So what will happen? Simply remove this voltage source, okay, and write the voltage equations independently for node 2 and node 3. See, assume that there is a super node over there. So simply we remove that voltage source. If that is the case, so we can simply remove that voltage source. Okay, now we have circuit like this. Okay, and we can write the equation for so again the same equation will be written over here, that simply assume that this is one node. Okay, so we can call that as super node. I simply write over here as super node. So if you write the expression for this, you can write this as V2 minus V1 divided by 5, exactly the same, plus V2 divided by 5, and since these two are exactly the same, so we can write this as minus 4 equal to 0. Okay, and here what is if you want to just consider this as how to write the expression for V3 in terms of V2. So if you look at the original equation and we assume that the voltage is 10I5, so this is node number 2 and this is node number 3, voltage at node 2 and voltage at node number 3. So we can write the expression for V3, because it is plus, it is minus, so we can write this like this, that V2 sorry, plus 10I5. Okay, so this is the expression for V3 in terms of V2 if you consider this as voltage source. And what about I5? I5 is here V2 minus V1 divided by 5. So V1 is 50 volt, so V2 minus 50 volt divided by 5. Now we have all the substitution, and we can simply substitute all these over here, and we can write the expression again. V2 minus 50 divided by 5 plus V2 divided by 50 and plus V3. So V3 is equal to V2 plus 10 I5 plus 10 I5 divided by 100 minus 4. And for I5 we have V2 minus 5 divided by 5. Okay, so equal to 0. So now we have one equation, one unknown, and that is V2. So solving this for V2, and V2 comes out to be 64. Very simple one. You can simply use your techniques studied in mathematics. So this is the voltage, which comes out to be 60 volt. So now we summarize our discussion. Okay. First case we discussed the use of dependent voltage sources. For dependent voltage sources, there should be no problem. You can use the method as it is, considering the reference nodes, label the reference nodes with voltages, label the essential nodes with voltages, assume one of the essential node as reference node, and proceed as it is. Another case is that when a voltage source is there between two essential nodes and one node is acting as a reference node. So what will happen? Simply take the node voltage is equal to the voltage, the value of the voltage source. So here, for example, V1 is equal to 50 volt, and if there is something else, you can consider that one. Another case is that when two nodes, essential nodes, are connected through a voltage source, like here, 10I5, there is a voltage source, and on one terminal there is essential node, on the other terminal there is essential node. So simply don't analyze the equation, the circuit for two different nodes. Consider that as a reference super node, and for that simply write only one equation instead of solving two equations or three equations and then adding or subtracting the two and removing the unknowns. So here we have this, and we have V1 unknown, and from the case the two voltages connecting the essential node, so we take the concept that one, V1 is equal to 50 volt, this unknown is done, V3, so we can write the voltage equation for in terms of V2, so we can write like this. I5 can be computed from here, so simply V3 can be written in terms of V2, so this is gone, so now we have one equation and one unknown, and that can be easily solved. So this is all, and in the next lecture we will consider mesh current analysis. So